Ever pondered why distance matters in supervised learning? It's a fundamental question that sends us down an intriguing path in the world of machine learning. Supervised learning, a key pillar of this realm, teaches our machines how to learn from labeled training data, allowing them to predict outcomes for unseen data. This is where distance-based methods come into play. They help us categorize this data based on the concept of distance. Imagine two groups of data points on a plane, each belonging to a different category. The distance between a new, uncategorized point and these groups could determine which category it belongs to. Intriguing, isn't it? Two main techniques help us achieve this: k-nearest neighbors, also known as KNN, and support vector machines, or SVM. These methods are fascinating in their own right, each with a unique approach to using distance for categorizing data. To truly appreciate these methods, we delve into the mechanics of each, starting with the k-nearest neighbors. K-nearest neighbors, or KNN, operates on a fascinating principle. This algorithm classifies new data points based on the majority class of its k-nearest neighbors. It's like asking your neighbors for advice and going with the most popular opinion. But here, the neighbors are data points, and the advice is their classification. Let's break it down. Firstly, we calculate the distance from the new data point to all existing points. This is like the new kid in town checking the distance to each neighbor's house. This distance can be calculated using various methods like Euclidean or Manhattan distances. Next, we identify the k-nearest neighbors. It's crucial to choose the right k as it can significantly influence the results. If k is too small, the model might be too sensitive to noise, outliers, or mislabeled data. On the other hand, if k is too large, the model might include data points from other classes, leading to misclassification. Finally, we classify the new data point based on the majority class of these KE neighbors. It's like the new kid deciding to follow the majority trend among his closest neighbors. And voila, that's KNN for you. It's simple, effective, and intuitive. But it's not always the best choice. Sometimes data points are not that simple, and a more complex method is needed. KNN, with its simplicity and effectiveness, indeed makes a mark. But what about when the data is not that simple? Enter support vector machines. Support vector machines, or SVM, brings in a different flavor to distance-based methods. This algorithm is like a brave knight who thinks, why should I fight all battles when I can strategically choose the most challenging ones? And that's exactly what SVM does. It identifies the most challenging data points to separate, and it uses them to construct an optimal dividing line, or in higher dimensions, a hyperplane. Now you might wonder, what makes this hyperplane optimal? Well, SVM aims to maximize the distance, or margin, between the hyperplane and the nearest data points from different classes. It's like setting up a buffer zone to prevent misclassification. The data points that fall on the boundaries of this buffer zone are the support vectors. They are the critical elements that SVM uses to determine the hyperplane. But life isn't always as simple as a straightforward division, is it? Sometimes data points are jumbled up in such a way that they can't be separated linearly. So, does SVM admit defeat? No way. It utilizes a technique called the kernel trick to transform the data into higher dimensions, where it can find a hyperplane that does the job. So SVM, with its knack for handling complex scenarios, complements KNN in the realm of distance-based methods. It's like having a Swiss Army knife in your machine learning toolkit, ready to tackle the most challenging classification tasks. So we've journeyed through the landscape of distance-based methods in supervised learning. We've delved into the intricacies of k-nearest neighbors and support vector machines. With KNN, we learned how it classifies new data points based on the majority vote of its neighbors, while SVM works by finding the hyperplane that maximally separates the classes in the feature space. It's important to remember that there's no one-size-fits-all approach in machine learning. The choice between KNN and SVM, or any other method for that matter, depends heavily on the nature of your data and the problem you're trying to solve. These methods, while powerful, are simply tools in your toolbox. It's up to you to figure out when and how to use them effectively. I encourage you to get your hands dirty, experiment with these methods, and see what works best for your machine learning projects. Remember, in the world of machine learning, distance does more than just separating points. It holds the key to understanding and classifying them. Until next time, keep exploring.